So this video is going to talk specifically about how we go about determining distance and displacement when an object is not just moving back and forth or up and down, but actually moving in multiple directions. When an object is moving both east and west and north or south, we have to change it up a little bit for displacement, but the good news is when it comes to distance, nothing changes because we don't care about direction. So for distance, we're still going to just look at what distance they traveled and add those two values together. So in this case, even though the biker goes to the west first and then goes north, going from their house to the stadium, we're still just going to add the 4 plus the 3 because even though the direction changed, it doesn't change the fact that they traveled a total of 7 kilometers. Now, when we get to displacement, it is a little bit different. Since the displacement is at an angle, it's not just on one plane, either just the x-axis or just the y-axis. We do have to switch it up. We can't just say, oh, well, that's to the west, so that's -4, and then 3 north. Well, that's positive because it's a positive. We can't just do that because they're not on the same axis. So instead, what we're going to do is we're going to use the Pythagorean theorem. It just so happens that with this particular example, the biker goes 4 kilometers west and then does a 90-degree turn and goes north. So that creates a right angle when we draw in the actual displacement. Because remember, the displacement is from where the object starts to where the object ends. And so when we draw that line and connect that line, we find that that actually creates the hypotenuse. So what we're going to do is we are just going to, hold on, give me 1 second here. Get out of that. Is we're going to use the Pythagorean theorem, a squared plus b squared equals c squared, where a is going to be one of the legs of our triangle. So we can make this one a. Oops, hold on. Oh, people, I'm struggling here. Here we go. So we can make one of the legs a and the other leg b. Okay, so we can then do 4 squared plus 3 squared equals c squared. Now using PEMDAS, we're going to do our exponents first. So we have 16 plus 9 equals c squared. Then we can go ahead and combine like terms. So we have 25 equals c squared. Now to get c alone, because c squared is different than just c, okay, we don't want to know what the square of this length is. We want to know what the length is by itself. We're going to take the square root of both sides. So c equals the square root of 25. And that happens to be a perfect square. So my displacement, this distance here, is 25 kilometers. Okay, so now let's look at this practice. In this case, we have multiple changes in direction. But again, we're not going to change how we calculate distance. We have a distance here of 2 kilometers, 5 kilometers, 6 kilometers, 3 kilometers. So we're just going to add those together to get our total distance, which is a total distance of 16 kilometers. But to find displacement, we're going to have to use our Pythagorean theorem. Now, I could theoretically do 2 separate right triangles because I have right angles here. But that would make me have to do the Pythagorean theorem twice. And let's be honest, I'd rather be a little bit more efficient. So I'm going to look at where my start point is. So that's my start, where the car is. And this is the end, where the house is. They're driving to their house. And I'm going to go ahead and I'm going to try and do this as straight as possible, but it's not going to be that perfect. But we get our hypotenuse by connecting those two values, or those 2 points, okay? But I don't have the right angle. I don't have the triangle yet that has that as one of its sides. So that is this value right here is my displacement, okay? Or is my C. But I need to go ahead and figure out how to make a right angle. So what I would do is I would draw a straight line going out from my end. Okay. And then I would draw a straight line coming down from my start so that they hit each other perpendicularly. Now I have that right angle, right? Now I have a right angle. So that's useful, but I need to figure out what is this whole distance here? What is the length of my A? If I make this my A and I make this my B, I need to figure out what is this total distance. Well, I know from here to here is 2 kilometers because that is what my original drawing said. So that's 2 kilometers. And I can follow this line here. I know from here to here happens to be 6 kilometers. So if that's 6 and this is 2, and again, I know this is 6 because that's in line. And we know from here to here is 6, which means here to here would also be 6. That means A equals 8 kilometers total. And I can do the same thing down here. I know that here to here is 3 because that's what it says. And then I also know from here to here happens to be 5, which means that B is also 8. Now that I have those values, I can go ahead and find my displacement. So I have c squared equals 8 squared plus 8 squared, which is 64 plus 64, which means c squared is 128. Take the square root of both of them, and I get that c is 11.3 kilometers. All right, take a minute and see if you can figure out how to do this one. This one is a little bit more complicated. I'll give you a hint. We're going to start off. This is the start point, and this is the end point. And you would start by drawing that, oof, that's a terrible one, but by drawing that hypotenuse between your start and the end. So go ahead, pause the video, and see if you can figure out how you would make your right triangle and calculate the final displacement. Okay, hopefully you paused, and hopefully you got something along the lines of this. You could either have drawn your right triangle downwards, or you also could have gone up instead, gone up to the X and then gone across. Either way, you get the same thing. You get 5 on one side, 10 on the other. This technically should be 11.2 because we would round a little bit. But you should have gotten 11.2 meters as that final displacement.